Okay, so this is going to be our intro to doubles and floats. So we just finished looking at integers, and now we're going to look at a couple of different number types. So our main focus will be on discussing the difference between floats and doubles and where we would use them in code. We're also going to go over an example, a real-life example of where we'd see floats and doubles and where we would use these as opposed to integers. So these are going to be decimal numbers, so anywhere where we need a decimal number we'll use one of these two instead of an integer, but we'll go into more detail in the part itself. Right, so now we're going to discuss another number type, and these are going to be floats, and we're also going to look at doubles. Okay, so floats, if I can spell it, and doubles are different ways to represent numbers, represent decimal numbers, but doubles have twice the precision of floats. And what I mean by that is that floats can represent up to 7 decimal places or 7 decimal numbers. So this means you can have as many as 7 units. So the decimal can be anywhere within those. That means we can have 6 before, 1 after, or vice versa, or anything. So for example, if we have, let's create a variable right now. We'll call this float1. So type float, and we'll give it the value of 5.5 just to start off with. It's fine, but basically I just mean that doubles can have twice the number of decimal places. So if we have a 5.5 here, if we have a total of 7 digits now, it's fine to display all 7 there. If we added more, then it still only displays 7. If we add a bunch in front, then we get the ones in front being displayed, so again always up to 7, and if we added a ton in front there, then we get, let's expand out, then we get it switched to scientific notation. Okay, so this will be float, let's just call this float2, and then we're just going to have float1 be just the 5.5. Okay, so as you can see here, if it becomes the issue of having more than 7 decimal places, it will switch to scientific notation automatically. Where doubles differ is we'll create this double one, and it will be of type double, and we'll give it the value 6.6, and it's fine with that. If we create this other one, double 2, and it will be of type double, we'll give it this value of 6. And we'll just, that's 4, 5, 6, 7, 8, 9, 10, 11, 12. It displays, let's see, we have 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12 decimal places there. So that's fine. However, if we add more, then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 being displayed there. Okay, so it's good for up to 14 decimal places, and that's why it's called a double, is because it has double the precision of a float. Okay, if we add some numbers in front of it, then it changes, so we get 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, and let's see, this view is really switching up on me, so 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14. So if we have a bunch of numbers before the decimal place, then basically it displays a maximum of 12 decimals and then at least 2 numbers before. In this case it's displaying all 4 numbers before, but only 12 decimal places after this. And we can tell because it rounds up to a 7 rather than a 666. Okay, so that's the difference between floats and doubles, is really that doubles contain double the precision of floats. Now you'll rarely need this kind of precision. Doubles are more useful when you're dealing with extremely large or extremely small numbers, whereas floats are better for the smaller decimal places where you don't need to be precise. For example, with money. So money will only ever have 2 decimal places at most, so that might be better to represent with a float, whereas something like planet sizes might be better to represent with a double. Now, the other thing is that a lot of built-in math functions, you take in doubles as parameters rather than floats, but the conversion isn't so difficult. We could just say double, and then if we take float 1, for example, that's fine to do that. It would just take float 1 and convert it to a double so that we can use it for any kind of equation. So this is again, a really good trick to remember, because there will be a lot of functions that can only take in doubles, can't even take in integers or floats. So be sure that you know how to convert just by calling the type you want to convert to and the variable you want to convert. Okay, so that's all good. Let's look at some examples of where we'd see these. Let's think of a bank account. So we have a variable, let's call this bank balance, and it's of type float. We'll give the value of 0 to start off with, and then let's have some constants this time. We'll let the transaction at this called deposit, it's going to be float, and we'll give the value of 500 and 50 cents, and we'll have a withdrawal. This is also going to be a float. Let's give this value of a negative 200, negative 223 and 98 cents or something. Maybe this was a purchase. There we go. Okay, so be careful not to do this, otherwise the compiler throws an error. So unary operator cannot go there. Separated from its operand, so then we just do this. As long as they're together, then it's fine. Okay, so then we can do something like, for example, we have our bank balance, and we're adding the deposit, and we'll also add the withdrawal. So we want to know what our balance is at the end of all of this. So after we add the deposit and the withdrawal, and we get $276.52. Okay, so this would be a good example of where we'd see floats, whereas doubles, we can think of a similar sort of thing. We can also use doubles in place of floats, but not always vice versa, because remember, floats have less precision than doubles. Okay, so we could replace these with doubles and it would all be the same. Let's see if we replace that with a double there. We get the issue here that we can't add them, so can't even read that, cannot be applied to float and double. But if we did this, oh, cut that off there, then we should be fine because we've converted bank balance, which was a double, to a float, and we've added the others. Okay, so doubles and floats not so different. The only difference is that doubles are more precise, so they can go up to more decimal places than floats can. Otherwise, both are good ways to represent numbers. Just be sure that if you're calling any of the built-in math functions, to check what kind of numbers it inputs, because if it only takes in doubles as an input, it cannot take in floats or integers. Okay, so if you try to feed those in, it will give you errors, but that's why we have this handy conversion trick to avoid stuff like that. Okay, so this has been doubles and floats. Our next tutorial will be looking at characters. Alright, so this has been our intro into doubles and floats. So just to recap, floats and doubles are both ways to represent decimal numbers, but floats can only have up to 7 decimal places, whereas doubles can be twice as precise and have up to 14. Also, doubles are used in many of the built-in math functions, whereas floats and integers are not, and also decimal numbers default to be floats, decimal numbers default to be doubles rather than floats. Okay, so there are going to be many times when we have to explicitly convert between one of the two, and we were shown how to do that by using the simple convert to the type and then put the variable in the brackets. Okay, so we use the example of a bank account to represent floats and doubles, where we might have money that has cents attached to it in which case we'll have decimal numbers, so integers would not be a good way to represent this money. And we looked at what the balance looks like after a couple of transactions. Okay, so this was also mixing constants and variables, but to the same result. Okay, so this next coming up part, we're going to be talking about characters.